Two poles are 70 meters and 50 meters tall, 70 meters and 50 meters tall. Their bases are located at a distance of 80 meters. A grounding wire needs to connect the top of the poles with each other and the ground. At what point should we connect the wire with the ground if we wanted to use the least amount of wire? So there's some kind of point where we're going to connect, and we want the wire, the least amount of wire. Like if we go way over here, connect, and that'd be pretty long. That'd be more wire, huh? If it's way over here, connect, and that's too much wire. So right in the middle. Well, I don't think it's right in the middle because they're not equal height. If they were equal height, they'd be right in the middle. But I do think it's closer over to the 71, because that's taller. So it looks about like that's probably, where exactly is that though? Is that to make the least amount of wire? This is the kind of thing companies, construction, engineers figure out when they design things. We will not solve this problem all the way, but only give the functions for the wire lengths. The function for the wire length on the left from the pole with the 70 to the ground, this part right here, in terms of x is, and there's the answer, how do they get that? So we this is going to be our L here. We're calling that L, L. How do we find that? Well, they said that this down here, draw there to there is x. It's where to say that. It said let x be the distance from the pole with 70 to the grounding point in the middle. From the 70 to the ground. That's x. So then look, we have a right triangle. We can do the Pythag, right? We can just go, oh, okay, so this is a squared plus b squared is c squared. So we go, okay. So a squared plus b squared is c squared. The a is 70. 70 squared. The b is x squared. Right? The a is 70, the b is 70, the b is x, and the c is L. Pythagorean theorem. Okay, and now we want L. How do we get it? We're going to root it, huh? Both sides. Oops. Now you might say, hey, Mr. You told us whenever you put a roof on the house, get up and down the ladder. Well, I'm not going to do plus or minus because it can't be negative. You can't have negative length. So remember, that's a general math rule, yeah, but real life applications, we know what's real. We throw away the negative. So, okay, so we get square root of 70 squared plus x squared. That's what L is, and that's what we got there. Okay, now how do we get the other side? Pretty much the same thing. It's a little more tricky, not a lot, but a little. We got to find this. What's this? Well, we know down here. Let me go down here. We know 80 is all the way, right? 80 is all the way, and this is x, so this must be 80 minus x, huh? Right? If the whole thing is 80 and take away this first part, the left part, then the right part must be 80, take away x, right? The whole thing is 80, take away x. This is 80, take away x. And this is 50. And then again, we're going to do the a squared, b squared, c squared. This is like a, b, c. So we're going to do it one more time. Just separate these guys right here. Just go, okay, here we go again. A squared plus b squared is c squared. A is 50. Right there. A is 50. B is 80 minus x. And C is actually that's our R. That's the right side R. R squared. Okay, so how do we solve for R? Again, take the square root. Oops, square root of the left side and square root of the right side. So it ends up being square root of 50 squared plus 80 minus x squared. There it is. There's the right side, 50 squared plus 80 minus x squared. So we were able to find a formula for each of these two wire pieces, the left side and the right side. And so what we would do, and this is just the setup, we're done there, but what you would do in general to solve this problem next, you say, okay, add those up. That's the total amount of wire, and then minimize that, right? You want to find what will make that minimum wire. So you take the derivative, set it equal to 0, and solve for the x value. Find out like how far over is going to produce the minimum amount of wire. That's what engineers do. But we're just doing the setup on this one, so we'll stop there.